Hi everyone, in this video I will show you tips and tricks to write SQL quickly and correctly. So when we write SQL queries, very often we get some trouble when we need to combine multiple SQL keywords like select, where, group by, having, order by, and so on. So for example, this SQL query generates a list of students with their number of graded submissions, the average assignment score, the lowest and the highest scores. But as you can see, this is generated by this 10 lines of code, which looks a little bit challenging, especially for beginners. So in this video, I will show you a strategy that you can follow to develop a long SQL query from something simpler, but you can develop little by little until eventually reach here. Alright, so here's the database schema for today's demo. And so we got two tables. We got student table, which has student ID as the primary key. And it also includes 4 columns, first name, last name, age, and the final grade. And we got another assignment table, where assignment ID is the primary key, and it has a student ID as a foreign key linking to the student table. And on top of that, the assignment table has assignment name, assignment score, the due date for each assignment, and the actual submission time made by the student. And for the demo, we got 6 students in the student table, and we got a bunch of other student submissions for all kinds of assignments. Right, so here comes the general strategy that we can use to develop SQL queries. So we got 2 versions, the one without group by and another one with group by. So let's start with something easier, the one without group by. So basically, the development process is divided into 4 steps. Select star from all relevant tables, work on the joins, narrow down on rows, and narrow down on columns. In the remaining part of this video, I will give you a few examples to demonstrate the usage of this strategy. Okay, so in the first example, we want to get the last name and age of the youngest student or students when there's more than one who finished assignment 3. Okay, so according to the strategy, our first step is to select star, select everything from all relevant tables. So what are relevant tables? So in this case, we already know the last name and the age, they are in the student table. But in order to know who finished assignment 3, we need to rely on the assignment table. So basically, we need to get the data from both student and assignment table. So we can write select star from student and assignment table. Okay, so these are our table names. Okay. And a good tip here is to execute the code to have a look at the intermediate result whenever you finish one of the steps. The second step is to work on joins. Because currently the table doesn't show any meaningful results because the data from the 2 tables are not joined correctly. So we need to write a SQL query where and joining the 2 tables based on their primary key and foreign key relationships. So this, as we know, these 2 tables are joined by student ID column. Okay, I mean they are linked by this column. Okay. So we can write this SQL query to work on joins and run intermediate results one more time. And now you can see the results looks much better. The step number 3 is to narrow down on rows. Because currently the results show all the student submission records, including all students and all submissions for all assignments. Okay. But we are only interested in the youngest students who finished assignment 3. Okay. So let's first filter the assignment name because we can know who submitted what assignment and whether the submission is made or not by looking at the assignment name column and submission time column. Okay, because if the submission time is null, it means the corresponding submission has not been made yet. Okay, so basically we are interested in those students who submitted assignment 3 and their submission time cannot be null. Okay, so we need to add that two columns and to filter out unwanted results. Okay, and assignment name equal assignment 3. Okay, and one more condition, and submission time cannot be null. Is not null. Right, so the intermediate result from this is 6 students who submitted assignment 3 and their submission time is not null. However, we have one more requirement. We only need the youngest student. Okay, so in order to get the youngest student, we need to sort the age column by their from the lowest to highest, okay, so that we can get the youngest at the top. Okay, order by age. Okay, order by age. Okay, so by default, order by age will sort out the age from the youngest to the oldest. Right, so as we already talked about, we only need the youngest one. So we need to modify how many records we're gonna select. Okay, select top 1. Okay, select top 1 and run it. Okay, so currently the result is much better. Only one youngest student, but with all the detailed information. So the last step is to narrow down on columns. Okay, because we don't need this many columns. We only need the last name and age of the youngest student. Okay, so that guides us to replace the star with these two column names. Last name and age. Okay, so this finally it will give us the required table view with showing only the last name and the age of the student who submitted assignment 3. Okay, so that's the strategy that we can use to write SQL query without group by statement. But if we do, if we have group by, then we need to extend the number step a little bit by identifying the columns based on which we perform group by and select that columns. And we can also expand the columns by adding all the aggregate functions like count, sum, average, and so on. And as a last step, we need to further narrow down on rows by addressing the halving requirement. So in the second example, we are going to show the names of assignments with more than 2 late submissions, and also show the number of late submissions for each assignment. Okay. So no matter what the requirement is, we can always work on step number 1 and number 2 first. Okay. They are relatively easy. So select number 1, select star from both student table and assignment table. Okay, select star from student assignment, and step number 2, work on joins. Okay, where the student ID has to equal assignment table's student ID. Okay, and run the intermediate results. Now, before moving on to step 3, let's analyze the requirement a little bit to clarify which is where, what is halving, and what is aggregate, and so on. Okay, so first, let's see. Okay, we need to show the names and also show the number of late submissions. Okay, so this is what we want to show in the resulting table view. Okay, so these are related to columns. Okay, so these are related to narrowing down columns. Okay, narrowing down columns. Okay, on top of that, we don't want all the records here, but we only want the assignments with more than 2 late submissions. Okay, with only assignments with more than 2 late submissions. Okay, so this is the filtering condition, okay, with which we narrow down the rows. Okay. But if you look at this requirement more carefully, it's a composite requirement with nested 2 separate requirements. Okay. With more than 2 late submissions and also late submissions. Okay. Late submissions. Okay. So how do you know whether a submission is late or not? You can compare the due date and submission time. Okay. So if the submission is made after the due date, then it is a late submission. Okay. So this information can be obtained by just comparing the submission time column and due date column. Okay. So this part is where. Okay. We can use the where clause to narrow down which submissions are made late. But in order to identify those assignments with more than 2 late submissions, okay, this information cannot be directly observed by looking at the intermediate result at this step. Okay. So this part of the filter has to be rely on having. Okay, having. Okay. So after this kind of preliminary analysis of the requirement, we can work on the next step. Narrow down on columns. Narrow down on rows, and using the where clause to narrow down. Okay, narrow down on columns. Narrow down on rows. Okay, so as we already discussed, the late submission part can be filtered by using the where clause. Okay, so we add that after the where clause. In order for a submission to be late, its submission time has to be later than the due date. Okay, due date. Okay, and run it. Right, so now we got the list of submissions who are submitted late. Okay. Next, we need to work on narrowing down on columns. Okay. Right, so first we show the names of assignments with more than 2 late submissions. So that guides us to think the group by needs to be made based on assignment name. Okay, because you can imagine in the resulting table view, we want to show assignment name followed by how many late submissions are made for assignment 1, how many late submissions are made by assignment 4, and how many are made for assignment 5, 7, 8, 10, 12, and so on. Okay, so the assignment name has to be included in the group by clause. Okay, assignment name. Okay. Alright, so a tip here is 4.1. After identifying the columns based on which we do the group by, that column also needs to be selected, okay, in order to avoid any SQL errors. Okay. So in this case, we are grouping by using the assignment name. Okay. So this needs to be used to replace the star we selected previously. Okay. Select assignment name from the 2 tables, and we group by assignment name. Okay. So a rule of thumb is you always need to make sure what you select here matches what you group by here. Okay. So as an intermediate result, we got 7 assignment names who has at least 1 late submissions. Okay. But we also need this part, show the number of late submissions. Okay. But in the previous filter, submission time greater than due date, we already got a list of late submissions. Okay. So we just need to count how many records are in each group. Okay, so in step number 4.2, we can add that one. Okay, aggregate one of the aggregates to count in each group, within each group, how many late submissions are made. Let me break down the into 2 lines, so make it look better. Okay. Select assignment name, count star from the 2 tables, and group by assignment name. I think I have, there's a typo here. Okay. Now I got the table view with assignment names and the number of late submissions for each assignment. Okay. Alright, so here, the table name is missing here, so it's a good idea to give it the alias name. Okay. Num of late. Num of lates, for example, okay, to just give it a nicer table column name. Right, so next step, okay, the final step is to narrow down on rows, because currently this is not the required result yet, because we are missing this one. Okay, we only need to show the names of assignments with more than 2 late submissions. more than 2 late submissions, okay, including 2 in this case. So we just want to tease out those results with only 1 late submissions here. Okay. So that can be done by using the having clause. Having. Okay. Having, where does this number come from? These numbers come from count, okay, count star. Okay. So we want the count star to be greater than or equal to 2. Okay, so finally, we got all the assignments with more than 2 late submissions, okay, including 2. Okay, let me show you one more example for the case when we need to use group by. Okay, so this time we want to show the student names, the average number, maximum score, minimum of their graded assignments, okay, but only showing the students whose this average is higher than 80. Okay, a lot of requirements. This sounds challenging for beginners. Okay, but if you follow all these strategies, okay, from step number 1 to step number 5, this can be decomposed into simpler tasks, and SQL can be developed little by little. Okay, so let's first work on the easiest one, which is the select star from all the relevant tables, and also work on joins. Okay, so this time I will do them at the same time, just to save some time. Okay. Select star from the 2 tables, from students and assignments. Assignment, okay. Student. To be careful, the table name needs to be correct, and they need to be joined by their primary key and foreign key linkage. Assignment dot student ID. Okay, and run an intermediate result. Okay. Right. So before moving on to step number 3, let's analyze the requirement one more time. Right. So first, we need to show student names. Okay. The names may probably including the first name and last name here. Okay. The average, maximum, and minimum of their graded assignments, okay, and only show those students. Okay, so these are what we need to show in the table view. Okay, so these guys are relevant to narrowing down by row. I'm sorry, narrowing down by columns. Okay, right. How about okay? This is another requirement here. Graded assignment. Graded assignment. So if you scroll down the intermediate view, you'll see a few table records are missing the assignment score. Okay, a few records are missing assignment scores. Okay, so the graded assignment means the records where assignment score is not null. Okay, so this is one of the things that we can directly see by looking at the current intermediate results. Okay, so this is related to where. Okay, do we have other requirements? Only for those students whose average assignment score is higher than 80. Okay, this cannot be seen by the current intermediate result. Okay, so this has to be done by using having. Okay, so after analyzing the requirements in the SQL, we can work on the step number 3. Okay, narrow down on rows where we need to use the where clause. Okay. Right, so this is what we need to use where graded assignments. Okay. So where we need to add one more condition where assignment score is not missing, not null. Okay, this way we should get all the records with graded assignments. Okay, graded assignment submissions. Okay, so this part is done. Next. The next step is to narrow down on columns. Okay, we don't need to show all the columns. Okay, we only need to show the names, average, max, min, and so on. Okay, so first work on identify the columns based on we do the group by. Okay? So imagine in the final result, we want to show for microgreen how many submissions, how many for microgreens submissions, what's the average, what's the max, what's mean, and so on. Okay? For Angela Red, what's her average, max, mean, and so on. Okay? So we want to group by these two columns now, and also show to first name and last name in the result. Okay? So that makes us group by the first name and last name. Okay? So as I said before, whenever we group by a certain set of columns, they need to be used to replace the star that we pre-selected previously. Okay? So run it. Okay? So this gave us a list of students without any other expected column names, including average, max, mean. Okay? So the next step is to expand the rows, expand the columns. Expand the columns by adding all the aggregate functions. Okay. Right. So first, we need the average one. Okay, average score. Okay. So select first name, last name, and average. Okay. What's the function name? Okay, AVG. The average of what? Average of assignment score. Yes, assignment score. Okay. So this part, I just the average. For max and mean, they should be easy as well. Max. Also, we want to get the maximum, the highest number in the assignment score column. Max assignment score. Okay, for a shortcut. Oops, let me undo twice. I just want to copy what I have already wrote and replace it with me. So now, if we run it, we get for each student what are their average number, average score, the high score, and minimum score. But again, adding a few column names will be nice. Okay. For average score, give it just average score, average. For max score. For mean, get it mean score as the column names. Okay, just to make it look better. Okay, so at this stage, we have done step 4.2. The last step is to narrow down on rows, okay, by using the halving clause. Okay. As we analyzed before, we only want to show the students whose average is higher than 80. Okay, the average is higher than 80, which means this number has to be higher than 80 in the final result. Okay. So this can be done by using the halving clause. Having this number, which comes from the average function. Okay. Having the average function greater than 80. Okay. So this will give us the last final result for all the students whose average score is greater than 80, showing their average score, maximum score, and minimum score. Okay, so that's all for today. If you like this video, please subscribe to my YouTube channel and also follow my other platforms. Thank you for watching.